sometimes in math, you get this idea of brute force. And so I've got this picture of Andre the Giant here, and from the movie Princess Bride. He's a brute, okay? And you might describe a brute as someone who's big and strong, but not necessarily super smart, okay? Whatever the task is, they're gonna get it done, but it might not be the smartest or most efficient way, okay? He might pound it with a rock until it's in the right shape, okay? Brute force is you're just going to do it through physical strength, and it might take you all day, but it's going to get the job done, okay? So in this case, we're talking about a brute force algorithm for Hamilton's circuit, all right? We're going to try to find the minimum Hamilton circuit. Remember, that's the least weight, the least total weight, and we're going to do that basically by finding all of the Hamilton circuits. So step 1, choose a starting point. Step 2, list all Hamilton circuits with that starting point. Step 3, find the total weight of each circuit. Step 4, choose the one with the least total weight. Okay? So this is not very fun. It seems kind of inefficient, but it's going to get the job done. Number 4 says find a minimum Hamilton circuit for the complete weighted graph. Now notice this is a K4. And we just learned a bit ago that this would have 3 factorial Hamilton circuits, or 6, okay? So I know there are 6 Hamilton circuits. The brute force method is going to make me look at all 6 of them, okay? Once you see all 6 of them, it'll be easy to pick the one with the least weight, the minimum weight, okay? So I think it just makes sense to start at A. So let's do that. Okay. If you started at A, you could either go to B next, or C or D, right? Okay. So if you go from A to B, you could either go A, B, C, D, and back to A. Or you could go A, B, D, C, and back to A. All right. So start over. If I was at A and I went to C second, you could either go from C to B and then you'd have to go to DA, or if you went from A to C, you could go to D third, BA. I'm just listing all of the different possible paths that I could take. Okay? The only other possibilities would be if I started at A and went to D second, I could either go to B next, and then I'd be stuck with CA, or I could go to C third, and I'd have to go to BA. 6 different Hamilton circuits. Those are the 6, but we need to look at the weights, okay? So here's how that works. Just look at the little numbers. And so if I go back to here and I look at A to B is 3. And B to C is 6. And C to D is 3. And D to A is 1. Okay? So if you add up those numbers, you'll get the total weight of that Hamilton circuit. So that's 9, 12, 13. That particular circuit has a weight of 13. So then look at AB is 3. BD is 4. And then from D to C, that's 3. And from C to A is 1. So if you add those up, that's 7, 10, that's 11. Okay. So then start back at A. And if I go from A to C, that's 1. And then if I go from C to B, that's 6. And B to D, that's 4. And back to A, that's 1. So that's a total weight of 12. But if I went the other way, let's see. A to C was 1, C to D was 3, and D to B was 4, and B to A was 3. That's going to be 7, 10, 11. That's 11. Okay. Are you way ahead of me on this? You feel like? Once you figure it out, it doesn't need to go this slow. Okay. So AD is 1. If I go D to B, that's 4. B to C, that's 6. And C back to A is 1. So that's a total weight of 12. And if I went the other way, AD is 1. DC is 3. CB is 6. And BA is 3. That's going to be 13. Okay. So you're going to pick the minimum weight. The minimum weight looks like 11, right? Oh, notice there's ties. Okay. Notice there are ties. Can anybody speak to that? Does anybody know why there would be a tie? Why it makes sense that there's a tie? See here? Exactly. If you go around one direction or you go the exact opposite reverse direction, of course that's going to have the same weight. That's going to be the same distance. Okay? So really, once you find the minimum weight is 11, pick one of those routes. This is the exact same thing. Okay? So it doesn't matter either way. A, B, D, C, A would be the minimum circuit. That's going to happen every single time. You're going to have a partner, I guess. That's the reverse trip. Think about it, though. There's a pretty major limitation for brute force. What is it? Can you imagine if we had to do that K6? When we talked about a K6 earlier, there were 5 factorial equals 120 Hamilton circuits. Can you imagine doing this for 120 Hamilton circuits? Okay, that's gonna really stink, and that really hammers home why it's called brute force. That's going to get the job done, but that might take a really, really long time. All right, I don't want to do it this way. I can do it, I will do it, but hopefully we won't have to do any with 120 of them. Okay, so the major limitation is may take a really long time. I think we'd much rather talk about efficient algorithms. Algorithms that do not take too much time. Fleury's algorithm is one. Brute force algorithm is not one. Approximate algorithms give reasonably good solutions most of the time. Okay, so an approximate algorithm, and that's what we're going to do next, will give you a pretty good answer, if not the absolute best answer. All right. So the nearest neighbor algorithm, I think you'll like this one a lot. Okay. Notice this graph is a K5. And so in a K5, how many Hamilton circuits are there? 4 factorial, which is how much? 4 times 3 is 12, times 2 is 24, times 1 is 24. There are 24 Hamilton circuits here. Brute force would make me calculate all 24 of them. Nearest neighbor is not. Okay? So example 5 says, a courier is at the head office A and must deliver documents to B, C, D, and E. The estimated time of travel is shown on the graph. The courier wants to visit the locations in an order that takes the least time. Use the nearest neighbor algorithm to find an approximate solution. Okay? So he wants to get around to every dot and back to the start. That's a Hamilton circuit. Nearest neighbor algorithm says choose a starting vertex. And then step 2, this is the important one, darken the edge with the least weight from your current point to a new vertex not yet visited. So look at A and see how you could choose any of these four right here. So just pick the one with the lowest weight. Now, yes, I realize there's a tie, so just pick one, I suppose. Okay, so let's darken this in right here. Okay, and so we've got A to B is 9, right? So now we're at B. And step 3 in the algorithm says repeat step 2 until you visited all the vertices. So again, we're going to darken the edge with the least weight from your current point to a new vertex not yet visited. So notice you could either pick a 3 or an 8 or a 10. Well, we're definitely going to go here. Nearest neighbor. Okay, think about what that means. Nearest neighbor, we're going to E with a weight of 3. Okay? Now, keep in mind, you don't want to go back to one that you've already been to. So we absolutely will not go to this 20 or go to A. We're not going to go there. We're only going to go to either C or D. We're going to go to one we haven't visited yet. And so if you're choosing between an 8 and a 5, you're going to choose this 5 right here. Nearest neighbor. Makes perfect sense. We're going to D with a weight of 5. Now, once you get here, you're kind of locked in. There's only one place you haven't been yet, and you have to go there, and then back to the start. So at this point, we're really locked in. Where do we have to go now? We have to go to C. There's no other option because we have to get that last point. That's a 7. D to C is a 7. And then we have to get back to the start. That's an A, and that's 13. And the fact that we got locked in there at the end, that's what makes this an approximate solution. Because if that last number is not very good, if that last number is a really high number, it doesn't matter. You have to take it, okay? So that could be maybe a drawback, is you might be locked into a big number there at the end. But we've got our Hamilton circuit, our approximate solution, A, B, E, D, C, A, with the total weight of, has anybody added those numbers up? 37. Maybe I added wrong. 25. I added wrong. Would you say 37? Okay, it's minutes, so let's use some units here. We've got this Hamilton circuit with a weight of 37 minutes. Did I do that wrong? Oh, I see. I picked a different way on my key that I'm looking at. I had gone this 9 first, and so I got a slightly different answer. Okay, no wonder. That's okay. We're good. This answer's better than mine. Anyway, 37 minutes, and that's it.